All right, I always get in trouble with this kind of problem. I've made some scribbles here. Here's what I'm talking about. Here's what now that I've got it, I'll start over. Okay, so let's say I'm an observer standing here on the ground. I'm just standing here on the ground. Here's me. For years, I said, well, this is the back of me or Barack Obama. So that would be Barack Obama. Here's the back of me. A little bit of belly there. Anyway, so here I am, and I'm watching this truck go speeding by on the highway. This truck is going speeding by on the highway, and it's got this guy in the back, and this guy throws. So here's the truck speeding along, and say it's going 45 miles per hour. Not really speeding or anything like this. And then here's a guy in the back of the truck, and he throws this baseball. He throws this baseball at negative 15 miles per hour. At 15 miles per hour this way. All right. So the velocity of the truck to the ground is 45 miles per hour. I'm watching this thing, so I want to know what the velocity of the ball to the ground is, because the velocity of the ball to the truck is equal to minus 15 miles per hour. You'd think that the ball looks like it's coming at me, but it's not. It's a strange thing, because the velocity of the ball to the ground is equal to the velocity of the ball to the truck plus the velocity of the truck to the ground. Right? So this equals minus 15 plus 45. So I see the ball sailing forward at 30 miles per hour, even though he's thrown it the other way. And that's what it looks like. The speed of the ball relative to the ground is a positive 30. So as soon as it leaves that guy's hand, it's, to me, an observer on the ground, it's going to the right. To the guy on the truck, it's going to the left. It's all about reference frames and which reference frame you're in. There you go. That's and we'll talk a lot about that next semester when we get to relativity, when physics starts to get really cool. I think it's just cool all the time, but then it starts to get really cool. All right, this has been long. Now these lectures have been this will be for all of next week. Okay, so these are for all of next week, all of chapter 3, and we'll wrap up chapter 3, and then I think, let me see our syllabus here. Whoa. You don't need to see people's grades. Luckily, that's not our class. Jesus Christ. Sorry. Can I get out of here, please? Can I get out? Help a brother out here, Blackboard. Please. Thank you. Jesus. All right. Anyway, sorry. So let's check this out. Hopefully it won't go to the grade center there. Those grades are pretty good. That's for my backyard physics class. All right, so let's check out the syllabus. I just wanted to see when the exams are. Make sure we're on the same page here. So let's call it the exam. Open. Okay, that's what we're working on now. February 6th. When is February 6th? I got to go to a meeting here pretty soon. Oh, February 6th is that Tuesday. Okay, good. That's what I thought. So we've got Tuesday and Thursday. Yeah, we'll wrap up chapter 3 without much trouble. and you'll have your first exam over chapters 1, 2, and 3. And then we'll start chapter 4 on February 8th. Okay? Hang it. I know this seems like, oh my God, yes, I filled the bucket with a fire hose today. And, these 3 weeks. But that's the nature of the beast. Like I said, if you were in a high school physics class, we'd have started this in September, and this is where we would be around Thanksgiving. All right? But we don't have that luxury. Or we'd have started in August, and this is where it would be. All right? So out here, have a good weekend. Have a good rest of your week. This is for the entire time now, remember. All right, so now I can